stop. Professor, everybody, good noon. Well, my name is Charles Lim, and my supervisor is Professor Joseph M. Spencer. And my project was chromatic detection of bacteria. So today I'll give you just a rough guideline of my project, and I hope you can understand it. So my project outline, very general concept of my project. This project attempted to use a LED as a light source to induce the fluorescence from bacteria, and we use a detector called MASET to collect the data, which is the RGB3 basic color bands, means red, green, and blue. And then finally, I will use a mathematical algorithm to analyze the results. So today's agenda. First part, I will give you some basic knowledge. Not so difficult because there are many components in my circuit or my project, but I will just give you the transistor. It's very easy, but it played a vital role in my circuit, so I hope you can understand it well. And then I will give you some information about my detection system. It includes some parts, so then some result present, and I will try to explain it to you how I collect the RGB data and how I analyze it, and of course conclusion. Then finally, maybe I will give you some good solution to improve my project. Okay, transistor, we all know it is very simple component, but in my circuit it's very important. Normally it comes from transfer and resistor, which means its function is transfer the bias from low bias to high bias. And why? Okay, I would like to use this simple equation to explain it. So once we can increase the resistor value, so the voltage should be increased. So therefore, if the voltage can be increased, as a result we can have a higher current. So finally, the voltage, the signal in the circuit should be amplified. And this is why we need it, because when I start to do it, first stage I'll need to detect the fluorescence from my medium, and I find that it's very difficult because the light intensity is too tiny. So if I can amplify my circuit, it will be easier to get the result. So this is my structure of my detection system. So you can see I use this approach to change the distance from 1 centimeter to 4 centimeter and try to detect you can say the target sample. In this project I use 4 materials to be the target. So when I use the white LED to light it, I hope if the target is bacteria, I hope I can successful to induce fluorescence from bacteria, then use the detector to monitor it. So here I'll show you some physical images. The detector, this is the MASET. Sorry, it's very small, but you can see it has 3 output RGB, so you can detect the light intensity and output the RGB3 color bands individually. And this is my structure. Very simple, but spend me a lot of time. So. And this is my target. I only show you one sample is oral soluble, because when in the final stage, it will be the main samples in my project. So yes, when we have the structure, the first part, so we have light source, of course, and detector. It's simple because it's just an AC device, and of course the sample. And according to the light source, we need a circuit design to trigger the LED. So here, LED, I don't want to waste time to explain it. I think all of you know it well. I use the white LED, 3 millimeter. And here I'm talking about that transistor is used to amplify the circuit. And of course, we all know that there's no resistor inside transistor. So here I use the variable resistor and connect to the base node to tune the bias. And I hope I can find the optimal bias to amplify it. So yes, and so move to the next. Here, I still give you a physical image. So here is the structure, and compared to the real image. So you can see the transistor here and the variable resistor. I use it to tune my voltage of current. And this is the first source, first target. So I didn't correct it. First target is the sweet, and cover some process paint. Just try to simulate the bacterial emit process. And yes, once we have a circuit, so I have to find out the initial voltage because I don't want to expose my LED, and each LED I think has different little bit difference characteristics. So I try to test it and find this curve. So I set up this safety array because I find that once I tune the voltage in this area or in this area, the signal will collect and my LED will be exposed. So finally I will choose the 2.2 voltage as my initial voltage. And then RGB intensity. So I start to collect the data from MAJET. So here is the image. The first stage I used it to do the initial test. So you can find this 3 curve, G, B, and R. So we can find that green color is the most intensity of this white LED. And this curve I didn't switch off the LED, so mostly I can say that is the results from the LED, the light intensity. But once I switch off the LED, you still can see the process, but the signal becomes just like a noise. So, well, it's, as I said, it's very difficult to collect process intensity because signals tiny. Even I use the transistor to amplify it, but still difficult test. And I would like to say, finally I use the 3 centimeter to do the initial job, start to test some different materials as my sample. So here is the